Hi, welcome back to the Chicago SAT review series, polynomials. And we have covered this topic by 2 videos already. We talk about how to combine the polynomials, and also we talk about how to find the zeros and the roots for the polynomial. And like I mentioned before, that one is the one most confusing to a lot of the students. So today, this is our last video for this topic of polynomial. We're going to really cover, that's what I put here, is miscellaneous topic of the polynomial functions. It's not any specific items, most, it's kind of like several general type of the questions here. So let's take a look at what we did for the first and second videos, right? So first video, we talk about combining polynomials. So we have like 5 here and another 4 here. So we total have 9 problems to talk about how to combining the polynomials. Like we say, the key part for that part is you need to combine the same terms, right? And be very careful about those positive and the negative things. And then the second video, we talk about how to find the roots, and then based on the behavior of the polynomial, how do we decide how many roots is there? So we have, I think we have like 5 problems here to talk about that. So today we're going to talk about the last video, and like I say, it's a miscellaneous topic of the polynomials. There's no specific items here. So let's take a look here, right? So let's take a look at problem number 15 here. And since the problem number 15 is pretty difficult to draw the picture in the whiteboard, so we can just cover it here. And then, we can go to the whiteboard, give it more space, we can work on the other problems. So for the video number 3, we have 6 problems to work. And those 6 are pretty easy problems here. Okay, so let's take a look here. All right, so these ones here, let's say the graph of the functions f of the g are showing below here. So this function is f, this function is g here. So they want us to find the value of x, like that. They wanted to find the f of x plus gx is equal to 0. So you look for this graph here. So the way you look at it, so you say, okay, when x equal to -3, let's see the fx plus gx will be true or not. So if x equal to -3, so you say -3 is, here is 1, 2, 3, so it's this point, right? Okay, so for this points here, and then the gx and f of x, gx is kind of 0, f of x is -1. So I know this one cannot be true, so this is not truth, right? Let's take a look. X equal to -2, so -2 is here, all right? So -2 is here, so you will see the gx is +2, and the f of x is -2. Oh yeah, so I find it. So this is our answer. Let's take a look at the -1 to see the -1 is true or not. So for the -1 is here, right? So here's a -1. Okay, so here's -1, and both of the f of x and the gx value is -1. So f of x plus gx is -2. So I know this one is not the truth here, right? So let's take a look at x equal to 0. X equal to 0 is here. Okay, so then the f of x is +2, but gx is negative, how many? 1, 2, 3, 4, 5, 6, 7, 8. It's 8. So f of x plus gx is -6. So obviously this is not the truth here. All right. So that's why, for this type of problem, you can just looking for the possible solution, and then you go to the graph and to identify it. Okay. So now we're going to go to the whiteboard and try to work on the other remaining 5 problems, because the whiteboard does have a little bit more space in here, right? So, okay, I'm going to quit here. I'm going to go to the whiteboards here. Okay, so let's work on that. So on the whiteboards here, right? So we are working on the problem number 16 here. So it says in the xy planes here, right? Y is equal to the 3x squared minus 14x intersect the graph y equal to x here. So in here, basically, this problem wants you to understand what I mean, the intersect mean. So if two graphs intersect, right? So that means if I have this graph and I have this graph, they intersect. So what's that means here? This is what we call is the intersect point. That means x and y. So this is the point, right? So this is the xy point. They both will satisfy, the both functions here. So for here, so because y equal to the 3x squared minus 14 intersect y is equal to x, so I know this y has to equal to this y because they intersect, right? So that's why I will have here. So I know the 3x squared minus 14x is equal to what? It's going to equal to x here. Correct? Okay, so when you equal to x, so I try to solve for x's here. So I minus x here. So I will have 3x squared minus 15x equal to 0. Oh, pretty good. I can factor the 3x out. So this is x minus 5 here equal to 0. Okay, so because so these two equal to 0, right? So that means this one equal to 0, this one equal to 0. So that means x equal to 0 and x minus 5 equal to 0. So when x minus 5 equal to 0, what is x? X equal to 5, right? And so, okay, so when x equal to 0, so what is the y value? Y equal to 0, right? So I know the intersect at the point 0, 0, because here, right? So when you substitute x equal to 0. So when the x equal to 5, what is my y value? Y is equal to 5, right? So I'm going to have a 5, 5 here. So that's why the problem say, hey, these two intersect and they intersect at the 0, 0 and AA. So here this is 0, 0 and this is AA. So what is the value of the A's here? A is 5, right? Okay, so that's what is the purpose for this problem they ask you here is what you need to understand what is the meaning of the intersection, right? Okay, let's take a look at number 17 here. So this is x cubed times x squared minus 5 equal to negative 4x. So they say, what is the one possible solutions, right? So what is the one possible solution? When we talk about the solution for the polynomial, that means if you can factor the term, then set all of them equal to 0, then each factor is a solution. Okay, so that means in here, I have these ones here. This is x cubed. This is x squared minus 5. So this is negative 4x here, right? So distributive rules here. Okay, so this will be what? X fifths minus 5x cubed is equal to negative 4x. So remember when we try to solve it, that means we set the polynomial equal to 0. So I need to plus 4x on the both sides. So I get x to the fifth minus 5x to the cube plus 4x equal to 0, right? Then what is the next thing to do in order to solve the solution for the polynomial? Factor, right? So what I can factors here? Okay, so, oh, wow, I have an x here, x. So I can factor the x out, so I can get an x out here. So I can get this is x fourths minus 5x squared and plus 4 equal to 0. And then I can factor these ones here, right? So these ones here, I can factor like this, right? So this is x fourths, looks here. This is x fourths, this is x squares, right? So what I can do is here, I can factor this is x squared and the x squared, right? Okay, so this is a plus 4, this is minus 5. So what the two numbers multiply will be positive 4, and then when they add together, it will be negative 5. What is that? It's negative 1 and what? Negative 4, right? Okay, so now this one is equal to 0. Now I can continue to factor. So I say, okay, so remember we said one of the very important formula we have is a squared minus b squared. This is equal to what? It's a minus b, a plus b, right? Okay, so for, the 4 here, I can change the 4 is 2 to the squares, right? So this will be x squared minus 2 to the square. And the 1, I can change 1 to the square. So I can use a squared minus b squared formulas here. So, okay, so let's try. So here, what is this one factor? Will be x minus 2, x what? Plus 2. And what is here? This is x minus 1. And this is x plus 1 equal to 0. So remember, that's how do we try to find the solution for the polynomial. We factor it, then set equal to each terms here. So how many terms I have? 1, 2, 3, 4, 5. So I set is this equal to 0, this equal to 0, this equal to 0, this equal to 0, this equal to 0. Okay, so now we know what is the value of the solution here. So x equal to what? X equal to 0. What is the next one? X equal to what? 2. What is this one? Negative 2. What is this one? Is 1. What is this one? Negative 1. That's right. Okay, so then you can choose which one is the possible answer choice. But those are the 5 possible solutions for this polynomial. So I guess for this problem, they want to test you 2 things here, right? So first thing here is how to find the solution for the polynomials, right? So that's what I want to tell you is you need to factors, right? So that's why the second thing that I want to test you is the factor to see you still remember how to factor those expressions here. Very good. Okay, now let's take a look at the next ones here. Okay, the next ones here. So let's say in the XY plane, point 2 and 5 is lies on the graph of the functions. If functions is equal to like f of x equal to the k minus x squared. So these problems here, they want to test you the concept. They say, if a point lies on the graph, what's that mean? The points lies on the graph here, right? So here we know this is my functions here. The f of x is equal to k minus x squared. So we know a point, right? So the point here is 2, 5. If it's lying on the graph, that means what? That means this will be, if you plug the x equal to 2, what is your y value? Y will be what? Equal to 5. Or sometimes you can call the y value is equal to the f of x, right? So that's what is we try to test you. So you plug the number in here. So this one pretty easy. So this is 5 is equal to what? K minus x squared. So this is equal to 5 equal to k minus 4. So you plus 4 both sides. So this is 9 and k is equal to what? K is equal to 9. Okay, so these problems here, they try to test you the understanding. What is they try to test you? They say if a point is on the graph, that means x equal the points. When you plug in, the x will be equal to when you plug in the y's here, right? That's what that means when a point lies on a graph here. Okay, so let's take a look at number 19 here. So let's say in the equation x sub 3 equal to 36, a is a constant. Then you want to find a solution again, right? So let's say, okay, I want to find a solution of the equations. So what is the possible value of a here, right? So in here, okay, so I know this is ax plus 3 square is equal to 36. So if I take the square roots both sides, so what happened to the left-hand side? That means if you take the square roots here, so if I say, okay, I take the square roots here, right? So I know my ax plus 3, right? So the square roots and 2 cancel, it can be equal to 6, correct? Or I know the ax plus 3 can be equal to the negative 6, right? Because when you square that, both will give you the positive 36. So when you take the square roots, you always have what? Positive and the negative. So that is what this problem tries to test you. So if you number, you take the square roots. So for examples here, so that's what they try to test you. If you say that x is equal to 49, then what is the x? X could be equal to 7, or x could be equal to negative 7. So this is the key concept. This problem tries to test you. When you take the square roots, you have a positive and negatives here, right? Okay, so now let's say if x equal to negative 3 is the solution, right? Okay, so that means for here, so this is a times negative 3 plus 3 equal to 6. Right, so this is negative 3a plus 3 equal to 6, minus 3 minus 3. So negative 3a equal to 3. So a is equal to what? Negative 1. Okay, so this is one solution here. A could be negative 1 here, right? So it's one solution here. Now let's take a look at this one here. So this one, I need to borrow the space down here. So this will be a to the negative 3 plus 3 equal to negative 6. So this is negative 3a plus 3 equal to negative 6, correct? Okay, so now you minus 3 both sides. So you have a negative 3a equal to what? Negative 9. So what is the a here? A is a positive 3 here, right? Okay, so this is why the possible answer for a, we could have negative 1 and negative 3 here. Okay, so remember, right? So what is this one? Try to test your concept. When you take the square roots, you have a positive and you have a negative. Don't forget about that. All right, so now let's take a look here. The last problem is pretty simple. This is 9ax plus 9b minus 6 equal to 21. And it wants us to find ax plus b here, right? Okay, so now let's plus 6 here, plus 6. So this will be the 9ax plus b is equal to 27. This is 9b here, and this is 9 here. Okay, so this is a plus 9b here, right? Oh, it's ax plus b. Oh, wow, look here. You say, hey, pretty good. I both have 9. What can I do here? Factors, right? So I can take 9 out. So this will be ax plus b equal to 27. Then you divide by 9 both sides. So what you end up to be? So the ax plus b is equal to what? It's equal to 3, okay? That's the solution for this one. And that's it. So these 3 videos covered most of the topics covered in the SAT test for the polynomial part. Like you see, some of those problems are pretty easy here, right? So you should be able to get a lot of credit if they have those type of the polynomials problems here. So like, not just try to solve it when you watch this video, make sure you capture the key things they want you to learn from each problems, right? So like number 19, they wanted when you take the square roots, you always need to have a positive and negatives, right? And number 18 is want to tell you what is the meaning when a point is on a graph, right? So those are the key concepts here. And how to find a solution for the polynomial, you need the factors, right? What is the intersect mean? That means x, the both of the graph, the y going to equal to y, and you solve the x here. Okay, that's it. And that's the polynomial. And it's a pretty easy topic. It's it's not a heavy topic in the SAT, but they do have like some easy problems later, 1 or 2 problems every time. So make sure you know the basic, right? Okay, so that's it. And if you have a question, feel free to send me an email. I have my email address at the beginning introduction slide. And also, feel free to subscribe to the channel so you will get notified whenever a new video is posted. All right, so it's so nice to talk to you. And our next unit we're going to talk about is the huge area in the SAT. That is the linear functions here. It's a line. And it's a cover, SAT cover that is very, very heavy portion in the SAT exams here. So I'm looking forward to talk to you and help you to prepare it. Okay, that's it. You have a good day and don't forget to practice it, right? Okay, talk to you later. Bye.